Now, can you see this coming off an amino acid somehow, maybe? One of the amino acids is bound to a carbon. Well, I don't know. This nitrogen here gets an H on it, so we're done with that. Color it in. We got a diamond there that's totally saturated. Color it in. A diamond there. Color it in. So there you got it. These are your hydrocarbon chains coming along here. So this is the back part. This part comes along. We're doing B5. There's a portion to B5 that goes with 2 phosphates. So let's draw this all out, how this all comes together here, since we're rolling on this. This is going to come to a phosphate, which is going to be a P, another P. Oxygens are what? Oxygens are green, so here's, I'm going to do this right, this is the star, right? So there's 1, 2, 3, 4. What's in the middle? There's an O in the middle. Let's make sure we do this right. We should have thought about this first. Oh boy. P is bound to P. We'll keep this in small notation here. O, P. P is a star, so there's.
Which would aid his agenda if he doesn't want to get involved in any more of these. Because I guess the more sour a taste he leaves in the mouths of Americans.
So we got double bonded O's on the stars, so we're just drawing those in. There's 1, there's 2. We got single bonded O's coming up here. 1. This is going to bond into diamond. This diamond is going to bond into another diamond. What that diamond is going to do is make a ribose ring. We're going to keep this way to make it look simpler. So diamond, 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 to an oxygen. So this will look familiar now after a while. This is the ribose. Let's see, we got to give them green hair out there. So there's a lone pair of electrons in there. Smiley face. You're too happy, huh? So when we're looking at this ring now, we see that there's another phosphate off here. So let's see how you do it. There's the O. To the star part. So that goes to an O. Goes to a double bonded O. So that's all green. This is all green. These are all green. Color them in. Whenever oxygen gets 2 bonds, just like everything else we do here, color it in. Color it in. So these are star P's. There's another phosphate. So that P gets the double bonded O, single bonded O, single bonded O, and then they call it an alcohol. So there's a circle, a dot in it. So the phosphates get a little confusing, but you just got to realize there's oxygens all the way around it. One's going to be double bonded. One might have a proton on it, so if it doesn't, it's going to have a negative charge out here. So it'll be happy, but actually, you know, that's the one we got to make him an alien, I guess, because he's got his own lone pair of electrons out there. So on the end of that is an alien. So these are phosphates. But the ribose sugar, this is what I want to come in on here. So it's really childish here, isn't it? But that's cool. This carbon here is going to go up to bond something else. So now all we need to concern ourselves with are these carbons. What I see coming off here is an alcohol. So there's a circle with a red dot. When I look at those carbons, I see they're just hydrocarbons. So let's draw our dots, dots, color them in so we don't have to focus on them anymore. 1, 2, 3, 4 bonds on that carbon. 1, 2, 3, 4 bonds on that carbon. Working our way across here, what comes on? This is part of the ring, so this carbon here was just a hydrocarbon. 2 H's on there. Doot, doot. Get her done. Color it in. Come to the next carbon over here. We already see it's got 1, 2, 3 bonds already. So it's got a hydrogen on it. Color it in. We're done. So now you can look real fast and say, hey, did we do the whole thing? No, look, we got this carbon over here that's not colored in. Our phosphates. Are the phosphates done? Let's color them in then, right? That's the beauty of this technique. And phosphorus is going to have an O bonding out here to something else, so we can color that in. So always think of PO4. PO4. And the minuses come and go. So you just got to know there's 4 oxygens on here. 1, 2, 3, 4. There's 1, 2, 3. This is bonded through an oxygen. So there's 4. So when we look here on there, now we finished the phosphate on that. Okay, let's color it in. Each point on the phosphorus is going to get an oxygen on it. So if it's free floating, has the potential to have 1, 2, 3 protons on there. What's the OH drawn as? 1, 2, 3. There's some double bond stuff going on in here. It gets a little complicated later, but that's the essentialness of a phosphate. You write that H3PO4. 3 protons that can give up. Triprytotic. And I'm telling you, I'm the only one that remembers this. There's phosphates in DNA, and they asked a physicist, beautiful, what was her name again? Rosalind Franklin. And she was correcting the chemist. Linus Pauling missed it, and Watson Crick didn't even have a clue. They said, where's the hydrogen? When they were looking at the B structure, the DNA. Rosalind Franklin, the physicist, told the chemists who had already stolen her picture. She goes, where did you even get that picture? She goes, there is no hydrogen. It's not protonated at that pH because you got 3 protons that can come and go on that phosphate. So this phosphate got its 5 bonds on there. Color it in. She's done. But she told them guys on a train how to interpret her X-ray diagram, diffraction thing. So now we're coming across. We look at that carbon there. It's got a hydrogen on it. So now that we're done, color it in. We're still not done. There's one more portion of this. This should probably be red up here because adenine is the one that's up there, but we're not going to mess with that. So that's the whole portion. This is the back side, has a sulfur on the back of it. Chain going along to 2 phosphates with another phosphate down there. We look. Did that phosphate get all its bonds? Yep. It's got a minus charge out there. It's got a alcohol on there, and it's got a double bond on there. It's a 5-pointed star for the phosphates. So see how that comes together? This is artistic, kids. That's a ribose sugar with 2 phosphates going off it. Yep. This is how it looks in the book. So I think it's kind of boring, but boy, it's a big old long enzyme there. You see it all? Right there, that's the whole thing we were just trying to draw. So we did the portion of it. So B5 is really important for your coenzyme A. Now I'm starting to see that because that's carrying all